Hi, everyone. My name is Tara Kraka. I'm assistant professor in the School of Architecture. I am also transitioning to direct the High Performance Building Lab, which you will learn about in a moment. It is my pleasure to moderate today's session on design and research at the School of Architecture at Georgia Tech. The panel today is going to be composed of Assistant Professor Keith Caseman, who's director of the Spatial Futures Lab, Ryan Rourke, who is the next fellow at Georgia Tech, and Danielle Wilkins, who is assistant professor with a focus on history and a background in technology. So each of us are going to be presenting our perspective on issues relating to design and research in the context of the School of Architecture, which is something that we are very excited about and always growing to be at a transaction, or basically at a conjunction between design inquiry and advanced research. Being part of a major research university puts us at the edge of knowledge as it unfolds. And we're hoping that today we are able to share with you some perspectives on our personal areas of inquiry as it relates to the built environment, as well as perspectives on what kind of teaching experiences or educational experiences you would have when you or if you join the School of Architecture at your respective degrees. So the format today is going to be that each of us, the four of us, is going to be presenting about 5 minutes of research discussions, whether it relates to our own areas of research or what we incorporate in teaching. And then we will be very happy to take your questions, and I will be moderating that discussion. Basically, when you post a question to the Q&A, I will be reading it and tagging my colleagues and friends here to respond to you. So I will start off with my lab, which is the High Performance Building Lab. If you were to join us on campus, you would see a poster that I typically use to introduce the lab. So I'm going to walk you through what the High Performance Building Lab is through that poster to give you as much as I can the experience that you would have had. So we are, at the High Performance Building Lab, a convergent research group. We are multidisciplinary with backgrounds in architecture, building science, planning, data science, and engineering, with the aim to disruptively transform design analysis of existing and new energy flows in and in between buildings. And we operate at multiple scales, and our area of focus basically is driven by the areas of inquiry that our students bring, as well as the research projects that we are leading in the lab. On your right, you are going to see a picture of the class in fall 2019. I also very highly invite you to follow us on all of the social media platforms we use. You can see all of the names for Instagram, Twitter, Facebook, and LinkedIn if you want to follow us. In this context, there are 3 areas of research that I would like to highlight, and that's not only what we do, but these are the 3 main ones. From the left, we are doing a focus on building performance diagnostics using drones, and that is the project called Aerial Intelligence for Retrofit Building Energy Modeling, AirBEM, which is funded by the US Department of Energy. And you can see a picture of a 3D building model that is using thermography to identify areas of vulnerability in a building that we are investigating. This is a collaboration between us, MIT, Syracuse University, and actually a local software developer called Pattern R+D, who are alumni of the High Performance Building program. In the middle, you will see building energy modeling. We focus on building scale and urban scale. So this is an example project funded by the National Science Foundation called Community Energy, in which we are collaborating with a community in Austin, Texas, to develop dashboard workflows to communicate through simulation how people's behavior and design decisions can change their energy performance. And on your right, comfortable and walkable cities. That's a personal topic of passion of mine, in which we are focusing on outdoor thermal comfort and its relationship to the walkability and bikeability of cities. And in this case, we are building models that translates people's experiences in the outdoor through integration of landscape, hardscape, softscape, and materiality to inform outdoor thermal comfort experiences. We continue to develop relationships with the public. So this was funded by the New York State Department of Transportation, but we also want to work with other departments of transportation as well. So these are areas of research in terms of teaching and things that you would be exposed to if you take courses related to high performance building. For example, on the left is the integrated building systems, which actually starts next fall, by which we are teaching professional Master of Architecture students simulation tools to inform design decisions, so that you can say Clay's work on the left here, looking at daylight availability metrics in a design that students bring from their studio and integrate into our coursework. In the middle, you will see building physics modeling and the work of Robert, who's analyzing climate data to inform design decisions, and also see future data to the lower here, basically understanding how climate change aspects can define built environment decisions to become much more performative. And to the right, our studio integration. I teach with Professor Michael Gamble a studio. In this case, I'm showing you this past year's work, where our students competed in a competition called Here and Now by the AIA and ACSA. This is the first place winner from 400 entries, called Another Life. This is Kang Song, who's an MArch student, with Dan Liu and Ronak Tiberwala, are both MS students in the High Performance Building Lab. And as you can see, this is highly articulated architecture that is informed by building simulation. And we are part of a community around the world. We host international events like SIMOD, which was here in 2019. We also contributed to the doctoral symposium this year, and basically always part of a conversation to inform building performance through advanced analytics. So I will show you two more examples, actually, fairly quickly, and one other competition. In this case, this is from the building physics modeling class by Kunan, who basically simulated energy performance, thermal comfort, and daylighting performance in a base case, so a before case. And to the right, you will see how the performance became better. So these are the kind of models that you would learn to use to inform design decisions. This is also from the studio, Saul, who was working with Dan Liu, who got an honorable mention in the same competition. So we got 2 awards out of the 6, first and an honorable mention, which she was developing a rapid deployable housing unit for disaster events. And in this case, the use of performance analytics, which you can see to the lower part of the page, is basically informing different climate data scenarios in Texas, Puerto Rico, and the Philippines, and designing renewable energy integration such as photovoltaic cells and daylighting analysis as well. And finally, our students also integrate with other competitions that are not necessarily in design studio. So this is the first place winner of a net zero energy building for the Race to Zero solar decathlon competition by the U.S. Department of Energy. This is in the category of urban single-family home, led by our PhD student Tyler Pillett, and of course a significantly integrated team of architecture, building construction, and civil engineering students to inform housing design to become much more performative and do performance analytics that basically create better performing built environments. So that's it for the basically representation of the high performance building research as it integrates to design specifically. I invite you to contact me if you have any questions, and of course follow us on all of our social media platforms, which is the High Performance Building Lab at Georgia Tech. With that, I would like to hand it over to Danielle. And Danielle and others, please let me know when you would like me to click next by just saying next. Thank you so much.
Okay. Thanks, Tarek. Hi, as mentioned, my name is Danielle Wilkins. I'm an assistant professor within the School of Architecture. I am very new to Georgia Tech. I started in the fall of 2019 and have been really enjoying things so far. I teach between architectural history and architectural design. So I'm really interested in actually where those two seemingly very similar fields actually don't overlap and speak to each other. And that tends to be more in the realm of visualization. So if Tark heads forward, a lot of the work that I do personally, but then also with students, explores how do we actually take information from the archive, whether that is using a physical archive that we would find at a library or a specific collection, or does it have the building and its surrounding as our documentary evidence? But how do we take all of that information and put it into some sort of vessel that is a little bit more interactive for the public? So architectural history and sort of heritage interventions that only speak to other designers aren't exactly useful in terms of us protecting, preserving, and enhancing our built environment. So a lot of what I look at is how do we take that information and leverage the fact that as designers, we tend to be a little bit more thoughtful of how we put information in front of people. So these are some examples of what some graduate students worked on this past fall in terms of doing a thematic timeline. So picking up some projects and putting them in conversation across time and place. My own research in part focuses on transatlantic design, seemingly kind of silo operations that are happening before mass communication in the 1700s and 1800s, and actually start to realize that there was a lot of conversation happening there, and that there were a lot of influences moving across the Atlantic Ocean for many different reasons. Moving forward, another place where this architectural history and architecture connect on the next slide showcases is where we can actually use construction technology and survey technology to explore the built environment. So Tarek, if you forward to the next one. There we go. A lot of this is facilitated by the fact that we have amazing tools at our fingertips now as designers and researchers. Some of those being aerial photogrammetry. So Tarek mentioned drones for the use of performance analysis within buildings. I tend to use drones for actually studying the built environment for preservation purposes. So analyzing buildings that are maybe in precarious situations and can't actually be surveyed with physical means because of structural concerns, or perhaps there's a timing issue. It looks like we went back, Tarek, if you want to stay on that last slide. Perfect. And so drones are really great ways for us to do quick surveys of large spaces and of buildings, like I said, that might not be in the best structural condition. And then we can meld that with 3D scanning, which is spectacular for interior surveys in terms of the levels of details we can get. When those two bits of information come together in point clouds, we can start doing what I call heritage BIM. So actually using building information modeling for historic structures, which is a little bit different than how we would use BIM in other regards, because none of the components are really replicable within a historic building. So I think it adds some really interesting challenges. So how do we take that information and use it for preservation planning, for structural analysis, for interpretation, how we get people interested in the built environment? Tourism is a huge part of the economic drivers in all of our nations, as seen by the close down lately. And one of the reasons we go to see things is because of the amazing heritage that's there. And then how do we perhaps recreate digitally things that have been lost or compromised over time? And so in the upper right, you're seeing a project that's actually looking to recreate portions of Selma, Alabama, and where Bloody Sunday happened, where we've had this pretty incredible vernacular landscape of the mid-century South, but most of it's been lost over time. So in order to fully understand that event and the context of it, we're digitally reconstructing some of the buildings that have been lost, and that we can actually piece together by using contact points from existing surveys of a few things that are still around, but then also essentially reverse engineering photogrammetry using archival photographs. So it's a little taste of some of the things we do both within required architectural history courses, but then how this interfaces into other design research that's available through research assistantships, but also some of the outreach that we're doing at the university. So there's a few things that are going on now, and we look forward to kind of getting our boots back on the ground in the fall. All right, so back to Tarek.
Thanks, Danielle. Keith, if you would like to instruct me on how to move forward, I'm ready for you.
Perfect. So, hi everybody. I'm Keith Caseman. As Tarek mentioned earlier, I'm an assistant professor at Georgia Tech. I've been here for a few years. I am also the director of the Spatial Futures Lab, which has been in existence for just a little more than a year. I also coordinate the Master of Science in Architecture with a concentration in advanced production. And so I teach studios at the design and research level, which is basically your third year or last year, second or third year. And also I teach hands-on seminars in the digital fabrication lab, or the DFL, which is an amazing facility. If you don't know about it, I would just go check it out online a bit. But it's an 18,000 square foot industrial grade production facility with all of the machines you need and more. And so, if you could go to the next one, Tarek. So the Spatial Futures Lab was started, it's embedded within the DFL, on the mezzanine within the DFL. And we basically work on multi-system design production, basically integrating mixed reality, augmented reality, drones, computer vision, robotic systems, and fabrication in an attempt to develop and explore and develop new ways of working. This is one of our core features in the lab, is this setup on this slide, which is a drone cage that has motion capture. It's got a motion capture system within the drone cage. We fly with an Xbox game controller. I'm not sure which one that is there, and we use the HoloLens. You can see the operational diagram on the right. Looks super straightforward, but it took about a year to set this up. I have several assistants in the lab, 2 from architecture, 1 from the GT School of Electrical and Computer Engineering. And we've custom built this integrated interoperable system where we can use a drone. Essentially, the basic version is we use a drone as a cursor, and we can model with it live through Grasshopper, visualized in the HoloLens using Photogram. So if you go to the next one, this is a picture of the very first time it ever worked, essentially modeling lines in space. And if you go to the next one, Tarek, and now we have a super thick robotic space. The data flow is actually from manual operation to that space, and vice versa into automated control of the drone. And the drone in this case can also be seen as a proxy because it's a robotic space. We can integrate all kinds of different systems into the. So next one, please. Other things we can do in this cage or in this space, this thick robotic space, is we work on full scale. It's a small space, but we can work on full scale ideas, small scale projects. You can see if you want to see these videos, I'll tell you the Instagram page later. And I'm going to be posting a lot of stuff. All this stuff is way more exciting with videos, essentially. But we can integrate physical tools with digital inputs, vice versa, and so on and so forth. So if you go to the next one, the most recent thing we've done in this lab was we ran a workshop at IAC in Barcelona, which is the Institute for Advanced Architecture in Catalonia. And this was really exciting because we spent such a great amount of time developing the system, developing protocols, and we basically packed everything up in a couple of cases and took it to Barcelona and set it up for 17 students in their Masters of Robotics and Advanced Construction program. And this was the first time that strangers got to use this setup to think differently, to imagine and project into the future with all these tools at hand. And it was super exciting. We just finished it up. I got back from Barcelona just before everything unraveled in the world. and I'm just beginning to synthesize all this, all the work that came out of it. So I'll be posting a lot of that too. Next one, please. And so when I came back from Barcelona, this was just a few weeks, or 3 weeks ago, I guess, um, almost a month ago. I came back to this, and so I teach the robotic a course called Robotic Operations, and my students and Memo, our PhD assistant in the class, co-pilot in the class, put a chainsaw on this Kuka robotic arm, and we were just ready to go and get started. You go to the next one, Tarek. Um, but instead, since I got back from Barcelona at that moment, I had to view the first cut via Skype, and it was very, very exciting. And of course, now we've switched to develop the projects and the workflows digitally for the end of the semester. But all that to say, we have a whole new bag of tricks to play with once we get back into the DFL with that robot who's sadly waiting for us. So if you go to the next one, all the work that we've done in the Spatial Futures Lab directly informs my studios and my seminars. And last semester, it was the first time that I opened up the studio to be directly tied to the lab, in the sense that its assets and all of our gear, like our HoloLens and a bunch of software and expertise, were used by the students in this. So next one. So this was all about mixed reality and design and production. We started by buying a 10-foot tall deer hunting platform, a prefabricated lightweight structure that could hold a lot of weight, and 4,000 feet of steel rod. And we modeled a small occupiable pseudo building. Let's say it's an occupiable billboard, some DJ booth, drone landing platform. We called it the beacon armature, as it was an idea that could hold all kinds of potentials. Next one, please. And we built it directly from the computer model, the digital model, to this, using nothing but a HoloLens and Hologram, the software that integrates Grasshopper and Rhino Live into the HoloLens. So there were no drawings involved at all. All of our decisions were discussed through augmented reality. Next one, please. And so you could see this very large construct was built very quickly, actually. Most of that work took place in about a month once we got our practices down. That's a 14-foot cantilever. This thing is, the total height of that projection billboard is 20 feet. I mean, the total height of the thing is 20 feet. And but it was quite an event. We worked together as a studio, not as a group of students with individual projects, but as a very agile, collaborative model. Well, we were all in it together, working around the clock, through excitement towards the end. Can you go to the next one? And like I said, all of this was built with just using mixed reality technologies, where you can see on the top of this slide that there's a kind of a targeted geometry that's predetermined, or designed and developed. And at the bottom, you can see the virtual tool, a virtual component embedded within a physical tool, a very low-tech hand bender. That's essentially how we put it together. Next one, please. And so it was very vibrant. The work environment was a big experiment that was playing itself out live throughout the whole semester. And it was very exciting. And you can see in the top, we actually had a real DJ for the kickoff to this semester, a real DJ in that platform, not just my playlist plugged in up there. So it was really exciting. If you go to the next one. The other component to this studio was that we used these same techniques. The groups of 3 or 4 students each used these same techniques to design drone ports, basically new topologies, and build 1/10 full-size mega models using these same techniques, using steel, using the bender, using Hologram, and then attaching augmented reality layers of information on top of it. So these are 3 different studio projects. These all happened within 2 weeks, from nothing to this in 2 weeks, because we had our muscles so finely tuned making that large construct along the way. So this is the first example of the Spatial Futures Studio. I think from here on out, I'm going to tie things that directly between the lab and the studio. So if you join, you'll be in space. You have the opportunity to join the mix and take round 2. So thank you.
Thanks a lot, Keith. So Ryan, you are up.
Okay. Thanks, Tarek. So I'm the next fellow. If you guys don't know about that program, it's a 2-year fellowship for early career academics, and there's a new one every year, so we overlap by 1 year, and everybody does very different kinds of research. You can go to the next slide, Tarek. I'm in my first year of the fellowship, and all of my kind of design and research work centers around intervention into historic buildings, so alternate or older buildings, not necessarily historic classified as such, but alternatives to demolition or whole preservation. So we have a lot of masonry building stock in Atlanta, and Atlanta also has a very deep history of demolition. So lots of I.M. Pei's first building was demolished relatively recently in Atlanta, and there are a lot of exciting buildings here that have been. But my whole approach is about kind of finding a balance, so neither being anti-demolition nor anti-preservation, but just figuring out how to do design in that realm. And so this is from a survey of buildings in London that I did as a KPF research fellow for 6 months in 2017. And in London, the reason for sort of looking at this stuff there is that they just have so much of this kind of work by necessity, because they have an extensive older building stock, and they also had extensive bomb damage in World War II. So almost every architect practicing there, although they're very quick to say we're not conservation architects, when I went to talk to them about this stuff, they all have to deal with kind of fitting into an existing context, often an existing building, when doing their design. So currently I'm teaching a seminar about how to represent these kinds of projects. And in fact, we're using some precedents from this particular list because they're already well documented, and we can then re-represent them. And the idea for that is, well, what I've noticed, I did my thesis at Princeton on a creative intervention type project, and it took about at least half of the term just to kind of represent the existing building. And although this kind of work is a large percentage of what is actually done in practice in the States as well as in the UK, we don't see as much of it in sort of studio and pedagogy, I think largely because of this representation issue, because there's so much baggage associated with representing something that already exists one-to-one. It's very hard to do that to our satisfaction before we kind of begin designing. So a lot of times you'll see either the kind of new or the old underrepresented, and I'm interested in representing specifically that balance and the relationship between the two. So in my current seminar, we are doing different kinds of models, collage, drawings, to think about how to represent this kind of project specifically. And at the fellowship, each fellow has a sort of like big deliverable associated with their fellowship. Mine is a planned exhibition about this work, so the London precedents, and then a studio that I'm teaching in the fall, applying this this research to a site in Atlanta. And I'm also doing a summer studio this summer based in Savannah on an existing building site that is something that is actually eventually going to be developed. It's a former dairy there in Savannah. And so the exhibition will kind of contextualize that studio work with this work. And so the current seminar takes a few of these buildings as the subject matter to represent them. We develop tools through that for how we will actually do representation in the studio. And that's the kind of sequence, is the seminar, then the studio, and then next spring I'll have another seminar on similar topics. So if you go to the next slide, Tarek. And this is a kind of typologies that I developed from the work that I did in London. It's by no means exhaustive, but it's a pretty good tool set to work with kind of masonry stock, which is again largely what we have here. And so this again was an idea of creating a pedagogical tool that to simplifying what I'm seeing in those projects in order to build complexity back up. So a lot of those projects are multiple of these, but these are kind of like a set of tools or moves that a student might look at, maybe combining like stratification and facade retention, and seeing what kind of approach to history that represents. I think of these things each as being a kind of attitude towards history and how we think of its role in the present, and how we think of what we're doing today as something that's kind of future history. So definitely my research ties very much into both of my seminars and future studio in the summer and fall. I also have 2 research assistants, one of whom works specifically on sort of at the material scale. So I think this project of dealing with combining new and old tectonic systems is fundamentally material. And so she's helping produce sort of a catalog of different kinds of materials, new technologies, biomaterials, and recycled materials that maybe up to this point people have mostly tried to use kind of for single material pavilions and things like that, and revealed limited uses. So the one example I always go to is the mushroom mycelium, which got a lot of interest, but then like it has 1/100th the compressive strength of concrete, so it's not going to replace concrete structurally on the exterior of a building, but it might be a very appropriate material for kind of interior intervention. And so the catalog that my research assistant Monica is producing goes through all of these materials, talks about kind of what level of durability, what level of use they're good for, and then also cataloging precedent projects to think about to look at how the material systems in those have played out. And then my other research assistant looks more at the kind of urban scale, looking at this question of all of the demolition and alternately the buildings that have been retained in Atlanta. So we're putting together an archive, which turns out to be, just compiling archives of like original plans and sections buildings around the city has taken us to a lot of different types of sources, but it's always exciting to find those original drawings. And yep, that's what I'm working on right now, and that's all I have. So back to Tarek.
Great. Thank you so much, Danielle, Keith, and Ryan. So I'm going to stop sharing my screen now and basically start answering questions in the Q&A. So this is all very exciting because of the overview and depth and breadth we are showcasing to everyone. So that's all very good. So I'm going to actually use the Q&A section, which we have 10 minutes budgeted as time, but I imagine that we probably will take a little bit more. So I'll start by questions that were received the most likes, and I'm going to consider this as votes. So, and I'm going to tag each of the panelists to answer a question as it pertains to their research or their background, or just background information as well. So the first question is, are research positions available to MArch students at either of the labs or all of the labs? I'm going to answer that part one of the question. Typically, MArch students may be involved in research as paid research assistants. And we've seen this experience across all the labs. You also may be taking courses and identified by a professor as someone who could be a great candidate to join a certain research problem or a certain research issue. But I would like to tag Keith for the second part of that question, which is, to what extent do MArch students use these facilities and these labs? So not just the digital fabrication lab. How do students from an MArch background or others use facilities in Georgia Tech and the School of Architecture specifically? Keith, you are muted.
Because my dogs just ran by. That's a great question, and I guess I'll bounce around a little bit, because first of all, the Digital Fabrication Lab is a facility that's open to everybody, and it's on the edge of. It's about a 10-minute walk from Hinman Hall, on the edge of campus, on this industrial corridor. So it's actually just a huge shop with the name of a lab, because it is a fab lab after all. The Spatial Futures Lab is embedded within that, and that that is kind of it's its own entity that's not open to everybody. So that's what I've been really excited about, was opening up those assets to the studio. So the studio, in this case, in my case, is the most direct kind of access point for a wide range of students, of MArch students, to kind of feel the palpably use what we've been developing in there. I think it's a similar scenario with you, Tarek, in the sense that the MArch students pair up with high performance students in the studio that you run with Michael. And that, I know from being on some reviews in the past, and just students currently in there with you guys, that it's a really great way for design oriented students to come but right up against the super kind of science-based approach that you take with the high-performance building, and how design decisions are informed as such. I think the only other thing I wanted to add to this was that the labs themselves, there's also, I mean, there are several other labs where there's the health and building, there's the space. I always forget the actual name of Thanos's lab itself.
Shape grammar.
Shape grammar.
It's a shape grammar lab. Shape lab. That's what it is. Shape computation lab. But so all this knowledge is cultivated within these labs and pushed into the studios, out to the students that way. That's specifically what the design and research studios are all about. That the faculty bring their research directly out from the closed doors into a wider environment. Does that make sense, guys? Did I answer that okay?
I believe so, Keith, because there's a lot of variety about how students can integrate with all of our research and basically lines of inquiry, not just the four of us, but actually all of the other faculty. So it's a very valid question, and one that is quite expected from a professional degree focus, and it is really based on the inclinations that the students have and the relationships you build with leaders of these facilities or leaders of the labs in general. So I'm going to take another question. This is by Harshika Seth. What kind of software should students be proficient in to access these labs? Is there some specific course I should take up as an MArch 2-year student to get accustomed for the same? So this is a very general question. So I'm just going to tag Danielle to respond to that question, not just generally, Danielle, but from your perspective. What kind of software that do you believe students would take if they want to join up with you, and how do you perceive other labs needing these kinds of software?
Sure. I think the sort of general basis that we're looking for is that you would have some familiarity with a CAD program of some sort. So whether that is within Rhino or Revit, and then also the Adobe Creative Suite are sort of the basis for presentations, how we take this information and then turn it around. So I think one of the things you noticed from all of us was that there is a big forward-facing part of this. So not just what we do within the Institute, but then how we take that information out into the public, and finding out how to make architectural drawings and research navigable to those outside of the profession is really important. Within sort of the 3D scanning and aerial photogrammetry work that I do, we use programs like Agisoft and AutoCAD Recap, get into some proprietary software that are made by the specific manufacturers, for example, Faro Scene. And we could probably name a whole list of things like that. But I think there tends to be a need to be nimble within software. And test things out, because sometimes you'll be within a program and not getting the kind of results you're hoping, or you need to combine a workflow. So needing to move between a number of different programs. And we're in this wonderful age where things are constantly changing. So I think one of the best things you could come to is just a curiosity and a willingness to learn, and a willingness to be a little frustrated at times, because that's part of the process.
Great. Thank you, Danielle. So I'm going to just add to that answer that it really depends on the kind of research pursuits you want to achieve. So for example, if you ask for the high performance building area of focus, I will tell you, you need to learn some basic simulation tools like Ladybug tools or Honeybee. You're going to be learning something like Climate Studio or its predecessor, Diva for Rhino. If we're doing advanced HVAC, you're going to be learning TAS, which software comes from EDSL. So basically, depending on the line of inquiry or research you want to be involved in, you will probably make some decisions early on what courses you want to take. You will have the basics. Everyone is going to be proficient in some CAD software. We typically use Rhino in this case in the lab. But then if you are going to be working in spatial futures, there's going to be a very different approach than working in high performance building than in working in historical documentation or historical analysis and contextual analysis in general. So thank you for that question. I'll move on to the next one. Are these research opportunities suggested more to the MS ARC path, or are they equally populated by the MS and the Master of Architecture program? And Ryan, I'm going to ask you about your experience with working with research assistants that come from the different backgrounds that you have integrated with, to highlight how all of these degrees can be integrated one way or the other. So the question is, are these opportunities open to both MS and MArch?
Certainly when I put out a call for research assistants, it was open to everybody. And the research assistants that I have, one is a senior who I believe is going to be an MArch student here in the fall. And then the other is a current MArch 2, so the 2-year program. And yeah, I mean, in my case, I have like hourly research assistants, so that was just an open call. I don't know if there's another kind of format in which that happens for master's students.
There is. So I am going to take the format that happens in the High Performance Building Lab. I primarily work with Masters of Science and PhD students with a significant degree of focus with PhD students because of the longevity of their stay at Georgia Tech and in the lab. However, I'm always looking to support Masters of Science students through both tuition remission and stipends that may be available depending on the research projects. So, for example, right now, the projects I have are all tied to students one way or the other. If I get a research project, which actually does happen, I can tag an MS student. So, for example, I have Norhan, who's working on daylighting research because the school was able to provide opportunities for her. And so it really depends on the situation and the kind of research inquiries. Now, can an MArch student come and work in the High Performance Building Lab, which is another example of not just the High Performance Building Lab, but other labs as well? Absolutely. Are the funding opportunities really available to them as a priority? Typically, there has to be a call out. I have to be working with someone, or someone comes with a skill set, and then they're attracted to join the lab in that format. So I hope that answers that question, and thank you, Ryan. So Carmen, I think we're going to take about 5 or 10 more minutes. I will try to leave 5 minutes between us and the next forum. So one question I know is not voted on, but I would like to respond because it is very relevant in all areas of expertise. Can MSUD students also participate in high performance building lab, and how? And I'm going to generalize this question. Can MSUD students or other concentrations participate in different labs, even if it's not their primary area of expertise or the degree they're seeking? And that answer is typically yes. There are different formats of how you can do this. So for example, I had an MSUD student take an elective course in the high performance building curriculum because they wanted to develop these skill sets. And then they come and ask if there are research lines of inquiry that match what they're doing. And for example, for the MSUD specifically, Professor Ellen Dunham-Jones has synergies with the high performance building lab. And so I imagine that someone who is not in the shape computation lab has a shape computation line of inquiry, would go to Professor Thanos Economou, talk with them, and basically attract their interest. So yes, we are moving towards a future, not just in Georgia Tech, but around the world, in leading research universities to be hyper interdisciplinary, if not transdisciplinary at all. So yes, you would be able to join depending on the skill sets you build and the lines of inquiry that would be available. So I'm going to ask a question to all of us, but basically it's more general than I would like it to be. But I know that everyone wants to know the answer to that question, and it's two parts. So someone was asking, do all of you offer research assistantships? And another one was adding to it. Rich was adding to it. Is it possible to receive research assistantship positions in the first year of an MARC 3.5-year program? So I would like for you all, just probably as a conclusion to the forum, to talk about research assistant positions if someone is admitted to Georgia Tech and does not have them. Are they able to join you in the first year? How can they build a path to joining someone that they're interested to join? So let's start with Danielle.
Sure. I would say one of the opportunities is actually to come as an hourly worker as well, as you've just gotten into school. So you might be paid as a research assistant for a project that maybe has a shorter window or has maybe a more limited budget model. So it might be kind of a proof of concept. As Tarek and others have mentioned, a lot of the projects that we work on are based on what funding is available from either an outside granting institution or from the institute itself, and some different initiatives that are going forward. So for example, Ryan and I put in something this past spring that would be tied to potential assistantships, and we're waiting to hear about that. So the hourly work is one option. I think the other thing to do is just be really proactive and reach out if someone has a particular research vein that's interesting to you, and you can learn a little. Also, option, this is going to be more at the 2-year MARC level or potentially within MS, but those are some opportunities. For example, I work with students for our large architectural history survey classes that undergraduates within the architecture program, but also across the institute take, and those students are really invaluable and have actually helped us develop some interesting things that have led to research projects. So there's a couple different opportunities, but one of the biggest things is just to be proactive as a student and reach out and try to get to know people and express your interest.
Thanks, Danielle. So Ryan, would you like to add anything to that discussion?
I mean, I would second that, reaching out, and because when you put out a call, and you're definitely going to have a leg up if the instructor already knows you. And also it's just a good way of sort of saying, if any of these kind of shorter term projects come up that you might want to be involved in, like keep me in mind, and we absolutely will, because it's always nice when somebody reaches out.
Great. Keith?
I mean, one of my grad student research assistant is in the first year, but she started in the second term of the first year.
Great. Keith?
Yeah, I think I would I would just add to that the situation, it's always super dynamic. You never know who's got what project going on, what's funded, what's about to happen, and so on. So I think I would concur with everything that's been said already. Just to kind of track down those who interest you, and just keep your thumb keep your finger on the pulse as much as you can. I know I have all of my assistants are currently hourly as well. And I would say, just to answer that question specifically about in the first year, it usually takes me about a year to find out who's got the troubleshooting nerves to join my wild ride. But I don't think that's the case all across the boards.
That's great. So I would like to add to that discussion that basically getting here is a start. Building expertise and defining where you would like to head is something that is very important as you're building not just your career, but you're building your time at Georgia Tech. So even if you think that you have certain inclinations, taking courses, interfacing with faculty and other students and also facilities as well, will help you in defining a path that is really more attractive to you. So you may think that you are ready to jump into some kind of line of inquiry, and then you join and you take this amazing course that is going to put you on a path of something that's very exciting for your career, and that becomes an opportunity to integrate with this kind of research. So we almost covered all the questions. There is, Keith, did you want to say something?
Yeah, just to point out that, just to jump on what you just said for 1 second. So that, a great example of that is Daniela, my current assistant. She came to Georgia Tech, had no interest in the digital fabrication lab. In fact, did not even visit it during the tour, and came across these topics in my core 3 studio, and now has become like the premier Jedi on all these super high tech things. So it happens all the time with the example that Tarek just put out there.
That's great.
The situation.
So there is a question about design and health, and Carmen has responded to it in the comments. So if you are interested in that, you should be contacting Professor Craig Zimmering, and there are links to that line of inquiry for sure. There is one final question that I would like to address. It's if students from a 2-year MArch decide to pursue a PhD degree after graduating, how does the school support them in terms of assessment, counseling, and financial aid? This is from Wesley, who I believe I've been in contact with. So I would like to highlight that, typically speaking, those who are in the MS track may want to continue into a PhD. It happens that those who are pursuing an MArch track would like to go into a PhD and have seen success in that. So for example, one of my PhD students, Eliana, is a PhD student after practice in Foster and Partners, and actually an MArch degree from UC Berkeley. So this path does exist. How does the school support? It is not necessarily the school. The mentorship that you are looking for is from direct faculty that you either want to link with for PhD pursuits or want to advise you on what kind of PhD opportunities may be available for you out there. So I'm going to take my example. I have a PhD. I'm able to mentor PhD students. And if you come to me and you say, I want to join the PhD program in high performance building, and I'm in the MArch, I'm going to ask about your skill sets. I'm going to ask about why you want to do a PhD. Mm-hmm. And I'm going to learn basically more about you and why a PhD is something that is necessary for success in your career. And then you would apply to Georgia Tech. For example, to join the PhD in high performance building, you're going to be assessed, there's going to be a portfolio, GRE, all of these things, and then maybe there would be a funding opportunity that allows you to join because of your skill sets. But you may also want to pursue PhD elsewhere. And for example, and I'm going to tag Danielle to also respond to this, for example, you are interested in an inquiry in history, and you want to join Georgia Tech, you're going to be talking to Danielle, or you're interested in going to other institutions. For example, you're interested in going to Princeton, you're interested in going to Harvard, you're interested in going to whichever institution that supports that line of inquiry. You're going to be talking with the faculty here, like Danielle, to help you in assessing your success in applying to these kinds of programs. So Danielle, do you want to add anything to that discussion?
No, I think that's good. It's just really about reaching out, and that we're very fortunate within an architecture faculty that we have pretty small student-teacher ratios compared to other programs. The studio model is based on engaged interactive learning. So having those kind of conversations are they're pretty common. I've definitely talked to students about this, and one the earlier the better. Oftentimes looking into a PhD program takes at least a year in advance, kind of get the ball rolling and to see what's around, and to, in some ways, kind of get your name into the field to see where you would fit within that inquiry. So I would say that's something, if you have an inkling, whether you're a 2-year student or 3.5-year student. I mean, I've had that conversation actually last semester with someone who was starting the 3.5-year MArch, and they said, I want to do a PhD, what would this look like? So it's definitely not ever too early to start asking and start learning a little bit more about it.
Excellent. So with that, because we have 3 minutes to the next presentation, I would like to thank Danielle, Ryan, and Keith for the awesome discussion. Carmen, thank you so much for arranging the event. Carmen, are we good to go? Should we? I think you can unmute and tell us we're good to go, right?
Yeah, we're good to go. And I invite everybody to join us in our next session for career planning.
Absolutely.
Thanks,
Thank you.
Great. Yeah,
You.
thanks guys. Good
Everyone.
luck.
Thanks,
Bye.
everybody.